Hello everyone, welcome back. Now in this session we will learn about higher order function. A higher order function is a function that either takes one or more functions as arguments or returns a function as its result. In JavaScript, functions are first-class citizens, meaning they can be passed around as arguments and returned from other functions. Higher order functions are useful for creating more abstract and reusable code. They allow you to build more flexible and composable functions, making your code more modular and easier to maintain. In this session, we will look into three different types of higher order functions. That is map, filter, reduce. We will also look into chaining method for function programming. So let's create a folder called 09 higher order functions. And within that I'm going to create a file called 01mapdemo.js. Now let's write the code to understand first higher order function called map. In this demonstration I am going to show how to use the map method to transform an array of numbers. The map method is a higher order function that creates a new array by applying a given function to each element of the original array. In the first line, an array named numbers is defined, containing the elements 1, 2, 3, 4. This array serves as the input data that will be transformed. The second line uses the map method on the numbers array. The map method takes a callback function as an argument, which is applied to each element of the array. In this case, the callback function is an arrow function, number equals number asterisk 2, which takes a single parameter number and returns the result of multiplying number by 2. As a result, the map method generates a new array called doubled, where each element is twice the value of the corresponding element in the numbers array. Therefore, the doubled array will contain 2, 4, 6, 8. Finally, the console.log doubled statement outputs the doubled array to the console. When this code is executed, it will print 2, 4, 6, 8 to the console, allowing you to verify that the transformation has been applied correctly. This example illustrates how the map method can be used to perform element-wise operations on arrays in a concise and readable manner. Next, let's look into another higher order function called filter. So let's create another file called 02filterdemo.js. Now let's write a code to understand how filter works. In this demonstration I am going to write the code that will show the use of the filter method to create a new array containing only the elements that meet a specified condition. In the first line, an array named numbers is defined, containing the elements 1, 2, 3, 4. This array serves as the input data that will be filtered. The second line uses the filter method on the numbers array. The filter method takes a callback function as an argument, which is applied to each element of the array. The callback function determines whether each element should be included in the new array. In this case, the callback function is an arrow function, number equals number %2 equals 0, which takes a single parameter number and returns true if number is even, and false otherwise. As a result, the filter method generates a new array called even, which contains only the elements from the numbers array that are even. Therefore, the even array will contain 2, 4. Finally, the console.log even statement outputs the even array to the console. When this code is executed, it will print 2, 4 to the console, allowing you to verify that the filtering has been applied correctly. This example illustrates how the filter method can be used to selectively include elements from an array based on a specified condition, making it a powerful tool for array manipulation in JavaScript. Now let's proceed further and look into how reduce higher order function works. So let's create a file called 03reducedemo.js. Now let's write the code. In this demonstration I am going to show you how to use the reduce method to compute a single value from an array of numbers. The reduce method is a powerful array method that applies a function against an accumulator and each element in the array, from left to right, to reduce it to a single value. In the first line, an array named numbers is defined, containing the elements 1, 2, 3, 4. This array serves as the input data that will be reduced to a single value. The second line uses the reduce method on the numbers array. The reduce method takes two arguments, a callback function and an initial value for the accumulator. The callback function is applied to each element of the array, and it takes two parameters, accumulator and current value. The accumulator is the accumulated result of the reduction so far, and the current value is the current element being processed in the array. In this case, the callback function is an arrow function, accumulator, current value, equals accumulator plus current value, which adds the current value to the accumulator. The second argument to the reduce method is the initial value for the accumulator, which is 0 in this case. This means that the reduction process will start with an initial accumulator value of 0, as the reduce method iterates over the numbers array. Finally, the console.log sum statement outputs the sum to the console. When this code is executed, it will print 10 to the console, allowing you to verify that the reduction has been applied correctly. This example illustrates how the reduce method can be used to aggregate array elements into a single value, making it a versatile tool for various data processing tasks in JavaScript. Now let's proceed to next topic, that is chaining method. So to understand chaining methods for functional programming, I am going to create another file called 05chainingmethod.demo.js. Now let's write code to understand the chaining method. In this demonstration, I am going to write the code for chaining of multiple array methods, map, filter, and reduce, to transform and aggregate an array of numbers. This technique allows for concise and readable data processing pipelines. In the first line, an array named numbers is defined, containing the elements 1, 2, 3, 4. This array serves as the input data that will be processed through a series of transformations. The second line begins the method chaining process by calling the map method on the numbers array. The map method takes a callback function, number equals number asterisk 2, that multiplies each element by 2. As a result, the map method generates a new array, 2, 4, 6, 8, where each element is twice the value of the corresponding element in the original numbers array. Next, the filter method is called on the array resulting from the map method. The filter method takes a callback function, number equals number 4, that checks if each element is greater than 4. This method generates a new array, 6, 8, containing only the elements from the previous array that satisfy the condition. Finally, the reduce method is called on the array resulting from the filter method. The reduce method takes two arguments, a callback function, ACC, number equals ACC plus number, and an initial value 0 for the accumulator. The callback function adds each element to the accumulator, starting with the initial value of 0. As the reduce method iterates over the array, 6, 8. The final result of the reduction is stored in the variable result, which will be 14. The console.log result statement outputs the result to the console. When this code is executed, it will print 14 to the console, allowing you to verify that the chaining of methods has been applied correctly. This example illustrates how chaining array methods can be used to perform complex data transformations in a clear and efficient manner. So guys, that's it for this session. In the next session, we will learn about optional chaining and newless coalescing.